Hello friends, welcome to engineering tutorial. So we'll continue with our discussion with the subject of fluid mechanics and hydraulic machines. So in the previous video, which was the first video, we discussed the basic concepts, the introductory concepts related to the subject of fluid mechanics and hydraulic machines. So in this video, we are just going to have a discussion on the basic concepts about fluids, which is the main part, okay, the core of this subject. Okay, so then we will discuss the other concepts associated, the basic ones first, and then we'll go on to the deeper concepts. Okay, so let us have a discussion about fluids. Okay, so we all know the matter is classified into three categories basically, but here we'll categorize them into two because the on the basis of the spacing between atoms or molecules. So we can classify them as solids and fluids. Everywhere we just see solids, liquids and gases, but here we'll categorize them, classify them as solids and fluids. Okay, liquids and gases we will keep it as one category. Okay, now this classification is based on the spacing between atoms or molecules. In solids, all the atoms or molecules, they're tightly packed with no negligible space between them. That's why they're relatively immobile. But in fluids, liquids and gases, this spacing is relatively more, actually very large in liquids and gases. In gases it is very high, in liquids it is relatively high as compared to the solids. Okay, so the fluids we can classify it as liquids and gases. Now this fluids, liquids and gases is the main part of the fluid mechanics and hydraulic machines, this subject. That's why I in this subject you will find these two are they are put in one category of fluids, liquids and gases. So in both liquids and gases, the intermolecular spacing, the distance between molecules or the interatomic distance, the spacing between the atoms or molecules is very high as compared to solids. In liquids, the spacing is low, the less as compared to gases. So this gives rise to various other concepts such as compressibility, viscosity, surface tension. All that we'll discuss in separate videos in detail, but this interatomic or intermolecular this distance, that plays a huge role, and it is because of that the liquids and gases, they find their place in the actuation mechanism, in process control, in various operations, in automation and instrumentation. So we have already discussed about fluids. So a fluid is a substance, okay, which is capable of flowing. It is because of the very high interatomic or intermolecular distance as compared to the solids, in which there is tightly packed, there is no movement, okay, they are immobile, they are not capable of flowing. It is because of this property of liquids and gases, combinedly called as fluids, they are capable of flowing, because the distance between the spacing between the atoms or molecules, it is very high, and they have no definite shape. They take the shape of the vessel or the container in which they are kept, and they undergo deformation, that is change in their shape, okay, when an external shearing force is applied on it. Now to understand a shearing force, you can visualize them as unaligned forces, okay, various unaligned forces, such that a particular group of forces acting on the fluids, they are uh, trying to move it in a certain direction, while the other group of forces are trying to move it in the opposite direction. Okay, so shearing force, you can define it as group of unaligned forces acting on a fluid in such a way that one group of forces are trying to move the fluid in a certain direction, while the other group of forces are trying to move it in the opposite direction. Okay, in opposite directions they are trying to move the fluid. This is what a shearing force means. So when a shearing force is applied on a fluid, it undergoes deformation, change in its shape. Now this change in shape occurs because it is capable of flowing because of its high interatomic and intermolecular distance. So fluids, it is divided into two categories, liquids and gases. So a liquid is a fluid which has a definite volume, okay, and all liquids, they are assumed to be incompressible. It means the mass per unit volume, it is fixed, it is constant, it is the same, it remains constant throughout. Although the liquids, they undergo compression, but that happens to a very small extent, okay, it is almost negligible, okay. So that's why liquids, they are assumed as incompressible. Example, water, blood, milk, whatever liquid substances that we find in our day-to-day life. Gases. Now the gas is a fluid which has no definite volume, okay, and it is compressible in nature. These are the two main characteristics on the basis of which the fluids can be distinguished, can be demarcated, can be differentiated. You can see in liquids, they have a definite volume and they are incompressible. They do not undergo compression, although it happens to a very small extent. That's why it is assumed to be incompressible. But in case of gases, they have no definite volume and they are compressible in nature. The mass per unit volume in the gases, it is not constant. That's why it is compressible in nature, and that to a very large extent. That's why you will find that large quantities of gas can be compressed into one small cylinder, one very small space, because the density is not fixed, the mass per unit volume is not fixed, okay. Now the examples are oxygen, hydrogen, carbon dioxide, etc. Okay, and then we have is the vapors. Now a vapor is actually a gas, okay, it is actually a gas whose temperature and pressure conditions are in such a way that it is almost closing on the liquid state, it is almost approaching the liquid state, on the verge of the liquid state. So that is what is classified or defined as vapors, okay. It is a gas with the temperature and pressure conditions in such a way that it is very close to the liquid state, okay. So liquids, gases and vapors. Vapor is just another thing which we should know, but mainly we will have liquids and gases combinedly called as fluids. Okay, now the types of fluids. Now there are the various ways in which the fluids can be classified, and we will do that in the upcoming videos, but a simple classification, this is one way of classifying fluids. There are other ways of classifying fluids as well, which we will discuss, but a simple classification or categorization of fluids can be done in this way: ideal fluids, and real fluids. So let us understand what ideal and real fluids are. Okay, an ideal fluid is one which has no viscosity, no surface tension, and is incompressible. And real fluid is the opposite. It has viscosity, surface tension, and is compressible. Okay, and here I am talking about fluids. It means liquids and gases combined. So we'll discuss about these properties, viscosity, surface tension, compressibility in detail, but for now you understand viscosity is that property of the fluid which for example, let us understand a very with the help of an example. The when we suppose a bottle is one bottle, we have two bottles. One bottle is filled with water, another bottle is filled with, let's say, tomato sauce, tomato ketchup. Now if we turn the bottle upside down, the water will flow easily, but the sauce, the ketchup, it will not have the same kind of mobility, the flow to it. This is because the sauce is more viscous than water. Okay, viscosity is that property in fluids which opposes motion, resists motion. Surface tension is the property of the fluid which opposes or resists any force acting on it. Okay, surface tension is that property. Compressibility, we all know, is the mass per unit volume. Okay, the fluids which have a constant density, they are called as incompressible, and which do not have a fixed density, they are called as compressible. It means the density is fixed, the mass per unit volume is fixed, means they cannot be compressed, they are incompressible. And if it is variable, then we can compress a large amount of a particular fluid in a very small space. So this property is mostly found in gases, but we'll discuss about that. And the ideal fluid does not exist. Okay, even liquids, they have compression, they undergo compression, although it happens to a very small extent, but still they can be compressed, but they are assumed to be incompressible because the degree of compression is very less. But still there is no ideal fluid, there is no ideal liquid or ideal gas. All of the fluids, liquids and gases that we come across, it will come under this category, real fluid. It means they will have a certain amount of viscosity, they will have a certain amount of surface tension and a certain amount of compressibility. It can be higher or lower, but they will have that. Okay, so this is one simple classification of fluids. There are other classification as well, but here these are the basic concepts associated with fluids, starting from the classification of matter, the classification of fluids, and the various definitions associated with it, and a simple classification. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.